This is SREB, Ready for High School Math, Lesson 2.4 on application of equations. Yes, anytime you hear the word application of equations, that's going to mean we're going to be dealing with some kind of a problem outside of just doing a straight up math problem. Okay? It means we're going to be given maybe some sort of a real world context to it. Now, this is more often associated as the word problem, which a lot of us don't like to think about. We don't like to think about that term, the word problem, but word problems themselves are not too difficult once we can break them down into the little bitty pieces that we need. So let's start with just kind of a little bit of a review and a little bit of a recap with these multi-step equations. So first step number one. So the first thing we want to do here is we want to take out this parenthesis by distributing the number that is directly in front of it. So we have a 4 directly in front of that parenthesis, so we're going to distribute it to everything in the parentheses. So we'll get 4 times x will give me 4x. 4 times negative 8 will give me negative 32. And then we'll go ahead and rewrite everything here exactly the same. So now from here, if there's anything on one side of the equation that can simplify, we want to do that. So cover up the right side. We have 4x minus 32. Can't combine anything over there. Cover up the left side. Look at the right side. So we've got a 2x and a 2x. We're going to combine those together. So positive 2x plus 2x will give me 4x. So this gives me 4x minus 32 on the left is equal to 4x minus 32 on the right. All right, now what I want to do, I want to take all my variables and move them all over to one side. So I'm going to take the 4x over here. I'm going to move it over here to the left. So I need to undo the 4x over here by subtracting 4x. Anything I do to one side, I got to do to the other. So I do that. 4x is canceled out on the left. I'm left with negative 32. And the 4x is canceled out on the right, and I'm left with negative 32. So I'm left with this statement, negative 32 equals negative 32. What we talked about, in a case of where we're trying to solve for x, and our x actually disappears because we completely cancel out our x's, and we're left with a true statement, something that is true. Negative 32 does equal negative 32. Well, then our solution will be all real numbers. And so in another way we could put this is that we have infinite solutions. Okay, so either of these answers will work for us. Either we have that all real numbers can be plugged in for x, or we just have infinite solutions to this equation. All right, so let's look at another problem. Okay, so this problem is pretty close to the first problem, but they do change it up a tad bit. So again, we have 4 times x minus 8, so just like last time. Come up here, distribute, we get 4x minus 32, just like with the first one. And we get 2x minus 32. Okay, so now with this one, we want to get all of our x's to the same side, so I'll move all my x's to the left. So I've got 2x over here on the right, so to undo this 2x, I'm going to subtract 2x. And anything I do to one side of the equal sign, I got to do on the other side. So 4x minus 2x will give me 2x minus 32 is equal to 2x is over here, cancel out, negative 32. All right, so now from here, I've got all my x's on one side. Now I need all of my constants on the other. So I need to get this negative 32 over here. So to undo negative 32, I'm going to add 32. Anything I do to one side, I got to do the other. So I wind up with 2x is equal to, because these cancel out, negative 32 plus 32, which will give me 0. Okay, so now I want to get the x alone. So I have 2 times x. So to undo 2 times, I'm going to divide by 2. So 2's over here cancel out. I get x is equal to 0 divided by 2, which will just be 0. Now keep in mind, whenever we get an answer of x equals 0, this doesn't mean that it's no solution. It doesn't mean it's all real numbers. It means we have a solution, and our solution is that we can plug in x equals 0. X equals 0 can be a solution for us. Okay, now we look at number 3. X over 2 plus 3 over 2x minus 8 is equal to 2x. X over 2 plus 3 over 2x minus 8 equals 2x. So no parentheses. So what I'm going to look for is, do I have like terms on the same side? Well, if I cover up the right side, I got x over 2 plus 3 over 2x minus 8. Well, keep in mind that this x over 2 right here, that is the same thing as 1/2 x. So really what I have here is I have 1/2 x plus 3 over 2x. Now, anything that has an x I can add together. It looks a little bit weird with these fractions, but if I add 1 over 2 plus 3 over 2, then according to the rules of fraction addition, if the fractions have the same denominator, then I add the numerators together. So 1 plus 3 will give me 4 over 2. The denominator will stay the same. And 4 over 2 will give me 2. So 1/2 x plus 3 over 2x gives me overall 2x minus 8 will equal 2x. Okay, and that's just something that if we get a little bit confused about that, we can always just type it into our calculator just to be sure on that one. But yeah, so 1 over 2x plus 3 over 2x will give me 2x. All right, so from here, we want to get all of our x's alone, okay? So right now, since I have only a constant over here, I'm going to just do the easy thing, and I'm going to move my x's to the right side, okay? Normally, I like putting them on the left side, but with this one, I won't have to move around as much stuff. So I'm going to subtract 2x. From here, I'm left with negative 8 is equal to, and over here, 2x's cancel out. Now, the 2x was the only thing on this right-hand side, so whenever I cancel that out, there's technically nothing, but we need to put something down to represent that nothing. So we're going to put a 0. So we're left with the statement negative 8 equals 0. Well, here's the thing. Negative 8 doesn't equal 0. That is not a true statement. So with this not being a true statement, that means that our solution is no solution. Okay, so in the case of where our variables cancel out, we didn't have any x's left over to where we could have a statement of x equals this. In that case, if we're left with a false statement, negative 8 equals 0, then that means that there is no solution. There's nothing that we could plug into in order for us to get a solution of that equation. All right, so all that was a little bit of review in getting ready for these next problems, which are going to be our word problems, okay? So with these word problems, we're going to be presented with a scenario, and we're going to need to identify key pieces in each scenario in order to help us solve what the question is asking us. So let's look at number 4. Suppose you are saving money to buy a laptop that costs $425. You have already saved $200 and plan to save $25 each week. How many weeks will you need to save money so that you can purchase the computer? All right, so what we always want to identify first is what are we solving for? Okay, so the thing that we're solving for is how many weeks. That's what we're going to be solving for. So the thing that we're solving for, we're going to have to write a variable for it. Okay, so in the past, whenever we saw problems such as 2 times a number plus 5 equals 6, that number in that thing, we always represent with x. Well, now this W is going to represent our number. So I'm going to put W to represent my number of weeks, okay, because this is the thing that I'm trying to figure out. Okay, so let's look at the information that I'm given. Okay, so I'm trying to save up money for a laptop, and the laptop, it costs $425. So I need to get $425 somehow, some way. Now, so far, I have saved $200. So I'm going to write that $200 over here. Okay? And I plan to save $25 each week. Okay, so if you think about this, after 1 week, I'll have $25. After 2 weeks, I'll have $50 because 25 and 25. After 3 weeks, I'll save another 25 and I'll get $75. So each week, I'm saving an additional $25. So a way that I could write that is, depending on how many weeks have gone by, I always save $25. So if I was to just make a table real quick, after 1 week, I'd save 25. After 2 weeks, I'd save 50. After 3 weeks, I'd save 75. After 4 weeks, I'd save 100, and so on and so forth. And so here's one thing to note. If I multiply this number, the week number, by 25, I get how much money I've saved up so far. 1 times 25 is 25. 2 times 25 is 50. 3 times 25 is 75. 4 times 25 is 100. So it seems that for each week that I save up, I am just multiplying the week number by 25 in this case. So a way that I could write an expression for that is I could say that I have the 200 and then I'm going to add, because I start with 200 and then I'm adding 25 for each additional week, I could write 25W, okay? And this may be a little bit of a foreign concept to us, okay? But if we think about this, 25W, this is an expression that represents what was going on in our table, okay? So as W goes up, okay, so as the weeks go by, I am getting an additional $25, okay? So that's how I would write this expression, as 200 plus 25W equals 425. And so this can now be an equation that I could use to determine how many weeks I will need to save in order to purchase this laptop. So now I have a two-step equation right here that I've set up. 200 plus 25W equals 425. So here's what I'll do. I need to get the 25W loan. So I've got a positive 200 over here. I need to get it away from the 25W. So to undo positive 200, I'm going to subtract 200. And I get 25W is equal to 225. Okay, now I've got 25 times W. To undo 25 times W, I'm going to do divide by 25. So I'll get that W will be equal to 9. Now, I have to think, what does W equal 9 mean for my problem? Well, keep in mind that W represented the number of weeks that I was going to have to save money in order to buy my laptop. So when W equals 9, that means that I will have to save up $25 every week for 9 weeks in order to buy that laptop that I want. Okay, that might have been a little bit of a confusing problem for us. So let's keep going through these next couple problems and see if it gets a little bit easier each time. Okay, so number 5. Mrs. Parsons and Mrs. Scoggin went to lunch at Olive Garden and spent a total of $30. Mrs. P's lunch cost $4 more than Mrs. S's lunch. How much did each person spend on lunch? Okay, so we're looking for two things in this equation. We're looking for how much did both people spend on each lunch, okay? So we're going to need a variable, but there's another little piece of information that kind of helps us. So we know that Mrs. P's lunch was $4 more than Mrs. S's lunch, okay? So in this problem, there's one of these people's lunches that I'm going to need to kind of isolate on, that I'm going to build the other person's lunch off of, okay? Because I'm going to need to write two expressions. One expression will represent Mrs. S's lunch, and another expression will represent Mrs. P's lunch, okay? So I know that Mrs. P's lunch costs $4 more than Mrs. S's lunch, okay? So keep in mind, whenever we talk about $4 more, or just think of it as 4 more than Mrs. S's lunch. Well, Mrs. S's lunch is our variable that we've talked about in the past, okay? It's our number, 4 more than a number. So we could use X to represent how much Mrs. S's lunch was. And if Mrs. P's lunch was 4 more than Mrs. S's, that is 4 more than X, which will be X plus 4. So now we've got two separate expressions. We've got X representing Mrs. Scoggin's lunch, and we've got X plus 4 representing Mrs. Parsons' lunch. So now we need to figure out how much did each person spend. So together they spent $30. So I'm going to take X, which represent Mrs. S, her lunch, plus X plus 4, which represents Mrs. P's lunch. So when I add these two together, I'm going to get a total of 30, because that's how much they spent in total for lunch. So from here, I need to figure out how much each person spent. So I'm going to take my like terms and combine them. X plus X will give me 2X plus 4 equals 30. Then let's get the 2X alone by subtracting 4. I'll get 2X equals 26. Get the X alone by dividing by 2. So I'll get X equals 13. So keep in mind, 13, this represented how much Mrs. S spent on lunch. And so X plus 4 would give me 17, which represented how much Mrs. P spent on lunch.